All right, yeah. So I thought we would start maybe with just talking about why we wrote the article, because I think that may be interesting to people broadly. I mean, in my view, I guess it started with Plateau in, I guess it was 2019. We had a session discussing how we might systematize research in PL and HCI, perhaps to end up with higher quality reviewing that is more predictable, and a set of standards that authors and researchers can write towards. And
telling students about what are the open problems in this space and what should they be looking at when they're looking for their next research area.
Exactly. Yeah. So we create an artifact out of that discussion that we've been having for a long time, and we wanted to reach as broad an audience as possible. So we decided to write a CACM piece. But there's still, in my view, this is still a lot of work to be done to make that vision we had a reality. I mean, I like this CACM paper. I think we got a lot of good feedback from it, but I still actually want to work more towards that original vision, which is to build a set of standards that the community can look toward to produce high quality research and review research with a more predictable result. And I think part of doing that effectively is identifying, as Sarah says, the most promising future direction for research, because you want to build standards not about what we did in the past, but about what we hope to do in the future. It's relatively easy to build standards in a mature field where people have been doing the same thing for 30 years. You're just sort of writing down the conventional wisdom of a field. I think our effort is fundamentally different. We're trying to build a community. The community already exists, but to expand the community substantially from where it is now, which is is still a relatively young and new community.
Right. So one of the things that we pull out in this piece in particular a lot is doing freestanding need finding work. And the fact that not every user study is an evaluative study. I think that's something that I would love to see more of in the literature. And right now, that's maybe not as much in the mainstream, at least in sort of the PL side of this space. And it would be really exciting to see more of that. And sort of what would it take to make our communities ready for that?
Well, you have that recent OOPSLA paper on need finding with Justin, right?
That's right. Yeah, I'm super excited about that. What are statically typed functional programmers actually doing when they sit down to write code and do all the things they say about what they're doing actually stand up? Turns out, no, it's really interesting to actually do some observations and watch what happens and then see what should that mean for their programming tools going forward, or even for the design of their programming languages.
Right. I mean, when I talk to my students about papers that they could write, I make sure they understand that not every paper, even in the CS department, has to be, and here we made this system and it works, cool. You can also write a paper that helps people understand what the problem is, right? And that's a significant enough challenge that it's a contribution in its own right. Publishing at that moment allows other people to work on the same problems that you've highlighted. And also you can publish that follow-on system paper that is well anchored in what people's problems actually are.
Potentially multiple follow-on papers, right? So Justin Lubin was the author of this work, the lead on this work. And I think he has identified at least 3 plausible follow-on works based on just the things that he observed in this one study. I mean, you can really uncover some really fascinating stuff.
That's pretty common. I mean, our work earlier, we got a CHI paper in 2020 about understanding how people do diagrams with existing tools, and it's the same thing. We built almost immediately. We built a system called Penrose, which addressed one of the major sort of design criteria we talked about in that paper. But there are 3 others, and we're still very actively working on them. I expect to be working on them for the next 5+ years, to be honest. Just to address the needs we identified from those expert interviewees. Yeah, I mean, I guess one thing I was surprised about in the course of writing this paper, which I thought was really interesting, and in the end we would call this PL and HCI better together, not PL and HCI, the standards for the discipline, is that I really think we made a very effective case for why doing these research in combination will yield more impact. And I think that we highlighted a lot of really impactful examples at this intersection, and I think there is a really a strong case to be made that doing formative research in the form of need finding, or getting design guidance from qualitative test studies or other sort of similar formative research, then following along with building programming systems which are inherently very flexible and provide a lot of power to the user, and then sort of finishing off with evaluative techniques that really center the user, is a way of really making an impact on practice relatively short order. I mean, in some of these papers that we highlighted, like Flash Fill and Sketch and like are already having impact on people's day-to-day lives. And I think that's really cool.
Yeah, in a certain sense, there's no shortcut to impact, but we're describing the aspects from both fields that, when present, increase the likelihood that it takes maybe a little bit longer to be fully scope out the problem, right, and make sure that the affordances that you're building into the programming system match those needs that you've identified. That you are more likely in the end to have the impact that we all hope for our projects.
Can we define affordances for the PL audience?
Oh, the same way that a well-designed door, right, communicates that on one side it should be pushed and then on the other side it should be pulled, because it's got a handle on one side and a flat place to push on the other. Having programming systems where what you can and cannot do is clear, and that what you can and cannot do is well matched to the tasks that people are trying to do. Those are generally good design elements that connect directly to the kind of need finding, say, that your student Justin was doing, or my at the time postdoc Tini Zhang led this interview study of API designers, right? And they are much like that paper. There's many papers that follow on from the insights of like, oh, API designers have no idea how people are using their API in practice and out in the real world, right? So any changes that they make is based on a hunch that it's being used in this particular way, or people are struggling with this particular feature, and so that just can motivate, like, oh, maybe there are automatic ways to surface that information for a designer.
One of the major stories I wanted to tell was, here's 3 people that have been relatively successful, at this combination. So, a thing I was surprised by our story is that I really think that there's a lot of research that's been successful. But for a lot of PhD students, the thing they care most about is career success at this stage of things. So that, to more important to them than, that Flash Fill is used, whatever, 100,000 times a day or 1 million times a day or whatever it's used is, you can get a top tier job at a fancy sounding institution based on it. So your jobs were very effective communicators. Yeah. So we started this paper by talking about our own stories, partly because I think they illustrate that it's reasonable to come at this intersection from multiple directions. And so my story is I had worked for 4 years as a software engineer, and the reason I wanted to go to graduate school is that I like working as a software engineer, but I really missed math. In particular, there's some software engineering problems that I encountered in my time there. In particular, we had been I created a lot of, let's call them, architectural drawings for the software I was building in those years, and the connection between the code I wrote and those drawings was really non-existent. As soon as the code was written, there was no way of enforcing that the drawing made any sense. And so I always felt like the communication we had at a high level was very useful for communicating across the team. Had more limited impact than it should because of this lack of conformance with the actual code we wrote. I came to grad school and I took the classes in programming language semantics and type theory, and I built a lot of formal systems for the work I was doing. I ended up building a language called Plaid, which enforced ordering constraints when interacting with APIs that have them. So, for example, if you're opening a file, you shouldn't read from a file before it's open. A lot of real-world frameworks have very complicated ordering constraints where specific things have to be done in very specific orders, otherwise they won't work correctly. And so I built this language, Plaid, for doing exactly that. And we built a pretty complicated formal system that improved its sound and implemented it. I spent years and years of effort doing all that. Actually, Sarah helped build an efficient implementation of that as an undergrad in maybe my 4th year of grad school. And then I came time to run my thesis proposal, and the things I wanted to say about Plaid, the claims I wanted to make about Plaid, were about how it would be effective at programmers. They would not write bugs that others write in their code, or they would be able to more quickly learn how to use an API. And so I had as part of my courses in grad school, I had encountered doing user studies. I took a class with Lori Craner on usable privacy security, where we had to run some user studies, turned into a paper later. And so I said, okay, this is a good claim, and we should do it. I should work on a user study to evaluate whether this claim is true about Plaid, whether people can in fact use it to effectively learn APIs, and whether when they use those APIs, they're less likely to be error prone. Well, those user studies basically fell completely flat on their face, because some of the mechanisms in Plaid, in particular the permission mechanism and the type state mechanism, which were two mechanisms we had in the type theory. People confuse them really fundamentally. That they just kept getting them. You couldn't keep them apart, and so no one using Plaid completed any tests at all. And in fact, people using the sort of status quo we were comparing to did much better than with Plaid in the short time we were able to give them. And so I realized pretty quickly, that was a pretty harsh lesson, that, you know, if I'm going to design a system like this in the future and want to make claims about users, which are the ultimate the people that actually use programming language, programmers are humans too, that I need to actually design with them in mind from the beginning, not just design with the proof in mind or design with the implementation efficiency in mind. And so since then, I've been doing a lot more formative methods in my research. Almost every single type of research I do, we start with interview study of experts, or a mining software repository study, or some other interaction with open artifacts, where we sort of glean from that the needs of real users, glean design guidance about how we should build towards those users, and then only then spend all this effort proving stuff and implementing and the rest. And that's been much more effective. In fact, Michael Koblenz, he was a PhD student I worked with very closely, built a system that was very close to Plaid called Obsidian. It was targeted at smart contracts, but the underlying formalisms were very similar. But we started in that case with these formative methods, with both interviews and with task-based, exploratory user studies. And Obsidian itself as an artifact is much more usable than Plaid ever was. We unified a bunch of concepts in the ultimate design that avoided the distraction I talked about earlier, and we ended up with something I think is going to be more impactful. It's already being borrowed by people in that space, in the smart contract space, by Solidity and other teams, and like the Ethereum Foundation, that are interested in building on that research. And I think that wouldn't be possible without the sort of formative and HCI research that we built into that system.
A couple of thoughts have come up while you're giving this more detailed view into the history of Plaid and how you've kind of come to the research practices you have now. So one of the very first things you said was, in the time that we gave them, they did better with the status quo than with Plaid.
Yep.
And that's always such a challenge. Oftentimes, usability studies are really a test of learnability, not ultimate capability once you are a master, right? And so I think that that can feel like a very limiting form of evaluation for people who are trying to build, like that next generation, that big leap. I think Nadia at UCSD has started thinking about doing longer term deployments.
I was about to say, yeah, diary studies or telemetrics. Like there are ways to do some of this.
The standard of what I do is typically that kind of like 15 to 22 people who each come in for an hour, and they have half an hour with each system. And we kind of already know from pilots that that the learnability is good enough that most people will experience the acceleration that they get from the system by the end of the session. Though there's definitely been situations where I've had a student come in for user study, and like they walk out the door after an hour being frustrated, and they go, "Oh, now I get it." And like, well, it's too late. But I hope that people don't think that they no longer get the freedom to make the beautiful thing they want to exist. I think it's just that when making claims about the beautiful thing, right, we want to make sure that the claims that we make about humans have the evidence to back them up. You just be aware of when you're not doing a formative study, because this is not motivated by the new observations you're going to get about the problems that they have. It's coming from internal.
One of the things I really like about sort of the way we actually do formative studies is that it's not about, okay, let's go and ask the user what they want, right? I mean, some folks do that, and it's not that you can never do that and should never do that. But I think much more common is you will watch their work practice. You will figure out, based on what you are seeing, what kinds of needs aren't being well served by their current suite of tools. And then that's the point where you go back and you start doing your brainstorming, right? You're not asking them to say, okay, what tool do you want? You're saying, okay, here are the gaps. Here's what I think might be able to help them. Let me go back and do all of that fun brainstorming. But maybe it's directed towards actually trying to solve a particular set of problems that are real problems, right? So it's not that this business of going out and creating something beautiful and new goes away, right? It's just that before we even start it, we know that we are working on something that's going to matter to some people. So it's not necessarily that we're really fundamentally changing this this researcher's process. It's really just that we're getting some extra information, some extra input before we start that really exciting process of inventing stuff. Right, because everyone's going to give this thing of like, okay, no programmer's going to ask for Haskell necessarily or whatever, right? Like that's the kind of critique that you'll hear. But that's not what we're going to the user for, right? We're going to the user and seeing sort of what are they facing, and then maybe at the end of our brainstorming process, we think up Haskell, right?
Right. They're not designers. They're experts. They're experts on what they're currently frustrated about.
Exactly.
Now, I will point out also, though, like sometimes, like people have frustrations about trying to get to and failing to get to the goals that they currently have. Right. And so those are actually the easiest obstacles to identify and say need finding or formative HCI, where you're like, okay, like person hitting brick wall repeatedly.
Right.
I'm going to go
They're
back.
Clearly mad about this.
Right. There's one other type of thing that we as PL designers can address, which is people don't even try to go over to that goal because they understand with the tools they have that like that would be impossible, right? Why would I try to do something that I know with my current tools is impossible? And so there, right, if you're trying to make something possible that was previously impossible, right, you can still try to understand what the obstacles would be should someone try the impossible. And so you don't have to be limited to people's current goals. You can imagine future goals and check in with people about like, hey, if you could do this, right, what would you do with it?
I think there's even a third category that I've been really excited about lately because I keep seeing it a lot recently of folks doing things in really like long, painful, frustrating ways, but they think this is just the way it is. And they sort of blame themselves. They say, oh, the problem with this is I just wasn't spending enough time on X, Y, and Z. That's really on me. I know that's right. But of course, no, there's some way to automate this. They shouldn't have to do this sort of manual, boring, tedious process. And there would be a way for us to give them programming support for it. But they're not even frustrated. They wouldn't even tell you. You'll just sort of watch their process and see that they're spending a lot of time on it. And then you realize, okay, actually, there's an opportunity there.
You're only frustrated about things that you expect to be different.
Exactly, right. If they expect that, no, that's just the process. They're not going to tell you it's a problem.
That's a great observation.
Yeah, so I want to quickly address Elena's learnability point, and then let's go move on to the other slides to have some semblance of structure. Yeah, so I think that Elena's right that the study design that we had for evaluating Plaid was really best at understanding the learnability of the issue with Plaid, and it's just from that description I gave you, you might think that it's possible that Plaid would be very effective after a significant amount of learning time, but I actually think that's a bit of a mistake in this case, because I think the usability issues that we saw, these fundamental confusion issues, or things that people would likely encounter even after learning. The quick things that you get from someone, the usability issues you observe in a lab setting are likely to generalize to people that in the real world, especially if you think about a tool that's used widely. Any issue you observe that people have in your lab are likely to be issues that people have when they interact with the real world. And secondly, the issues of learnability, especially when you're related to adoption, are really fundamentally important, right? If people are going to give up in frustration quickly, then you have a very low chance of being successful. And ultimately, I think the design we built into Obsidian that was improved based on this sort of formative research was just as expressive and useful as what we had in Plaid, but just ultimately more usable. And so why would we run with the thing that was maybe easier to prove, or the first thing I came up with, instead of the thing that was that was more learnable and less confusing. And so, but that being said, I do think there are longer term studies of various sorts. Or with Penrose, we've been doing these what we call long-term case studies of expert diagrammers, so people that are using our tool for months and observing how they do it. I mean, it's hard to do an A versus B study in that way to get sort of quantitative distinctions, because no one's going to commit to using your tool for months in a comparison study on a task that they don't care about. But they are willing to work with, if assuming you built something that people like, they can be willing to work with your tool for long periods of time on the task they care about. And so you can definitely leverage that for interesting data. And so we basically do diary-based studies where they while they're using it, they write down answers to a set of questions at set points, and then we also occasionally watch them work, in a live way to observe anything that they're not observe something about them that they don't necessarily observe themselves, and so that can be very useful. Let's switch to Elena if you're willing, Elena.
Sure. I kind of almost accidentally backed into PL. I was working on information visualization of programs because I was this frustrated TF with way too many students all writing very complicated programs in a.
Sorry, what's the TF? Is TF
Yeah. Same question.
That's a Harvard TA. I used to have trouble saying TF, and now I have trouble saying TA. Yeah, so I was a teaching assistant in a massive computer architecture class, and the language in which students were constructing these simulated risk processors was a language invented by the professor who ran the class like 20 years ago, and it's completely impenetrable. And so I would go from student to student trying to help each one, and they're like, "Here's my code, what's wrong?" And I'm like, "Oh God, like this is not the right balance between computer computation and human cognition. Like there's some mismatch here." And so I started working on trying to show populations of programs. So Overcode showed thousands of student-written Python programs in a massive open online course when that was very popular. And people could make more accurate judgments about the distribution of design choices that their students were making. However, each time that I made one of these visualizations for a pile of programs or interface for rendering that kind of program, there was a certain kind of fixed nature to it in terms of I was making choices that I was hard coding in, and really what I wanted was the teacher in that programming class to be able to say, here are the critical components, or to make annotations and to be able to kind of interactively construct these views themselves to best serve the questions they had about the programs that their students in these massive classes were writing. So anyway, I never got to that in the PhD because it was like, oh, I would love that to exist, but I have no idea how I would do that. And then I got accepted into Bjorn Hartmann's lab on the NSF Xscape project. The last year funded the first year of my postdoc. And the NSF Xscape was all about computer aided programming, and he was the one HCI person on a big PL grant, and so I was the one HCI postdoc, and so people are calling me and saying like, hey, we heard we should do user studies, can you help us? And I would try to give them advice, but also I had to do a project that used program synthesis by example. Like that was essentially a requirement of my first year, was one project had to use PL technology, and so that's kind of how I stumbled into PL and was like, oh, program synthesis by example, or this whole, which opened up the whole wealth of synthesis, allowed me to start playing with cutting edge technology where I could ask users to give input to the computer in their own, in a form that was most comfortable to them. That was providing examples, that was also highlighting parts of programs, and adding a comment that was human written rather than like generated by some template. We in our more recent papers allow people to give an example, but also annotate what about the example they should the synthesizer should absolutely adhere to. Like that is a literal thing. I want this to start with a plus sign, versus, oh, these numbers, these are just general numbers. There's instances of the number, right? And make all these different ways of making it natural and easy for people to specify what they want, and also for the results of synthesis to be reflected back to them both during and after synthesis, so that they can work more effectively and get to where they want to go faster than they would have had they were programming alone. So we're still working on, can we kind of interactively allow people to kind of author these templates that kind of render these large populations of, say, code examples out in the wild of how someone's using their API. But PL technology has ended up being a real engine for powering more natural specification interaction models with our users. So that's
a question I have based on this is, what do you think is special about PL technology that lets it be useful in this way you just described?
Well, so why I get really excited about synthesis specifically as a tool rather than, say, a neural based synthesizer or so kind of few shot machine learning techniques, is that what is returned is a program that, even if that program is not readable enough that I would actually show it to the user, I can kind of I can do computation on it and figure out, like, here are the key inputs that if I show will kind of show you the diversity of what that program would do depending on the domain that it's applied. I prefer to work with the program as an object, it comes with a lot of nice properties.
Yeah. So what about so you've compared it to machine learning or neural network based approach, but what about to sort of traditional GUI-based approaches like you might find in HCI and other, in more traditional settings. The abstraction composition mechanisms that are sort of inherent to programming languages are really needed by sort of everyday users to do the tasks that they care about, because the sharing and the structures from simpler parts is something that everyone needs, not just software engineers. Is that a fair summary?
Yeah, and I think the fact that Excel is understood, like it's not like people are like, why do you need Excel for this, right? Like the fact that Excel has it's one of the most widely used programming languages, right? People make use of the flexibility that it gives them. It's an incredibly powerful tool because it has a programming language underneath it. Certainly, you don't need a programming language for trying to think of like the most where you cross over from a GUI without any kind of like programming language behind it, without the ability to kind of compose these abstractions. What's the most complicated thing where that's not necessary? I was going to say like a smart home, but even there, I mean, people may want to describe programs to control the smart devices in their house. So
I was going to say even something like Photoshop, once you get into the advanced features, you're basically programming.
Many GUI-based tools under the hood are eventually giving you the flexibility of programs, but the interface that they're giving to you maybe isn't the best one, and that's part of what I think HCI can learn from PL. Okay, do you want to move on to Sarah's things?
Yeah, so looking back many years, the actual reason I first got interested in research in the first place was to make programming more usable and to basically try to make it more accessible to more folks. I had observed a lot of my, very smart friends who really like logic puzzles, not really enjoying programming, which I thought was rather surprising. I didn't really understand what was standing in the way of them getting up and running with this stuff, even when it would have been useful for them. And so that got me interested in what would it take to make programming easier. And that led me first it led me to Josh's project on Plaid, which was super fun. And then the year after that, when I was picking grad schools, I was looking around and I got interested in how programming by demonstration and by programming by example might end up helping. And so that led me to Ross Bodick's lab, where I did my PhD. And along the way, my interest in sort of making programming easier evolved a bit to making just sort of more diverse tools that would allow more diverse audiences to start doing the kinds of automation they needed. So sort of stepping away from, okay, let's make it easier for more people to sort of join the on-ramp to becoming a software engineer, and more towards, okay, there are lots of different people who could benefit from using automation. What would tools look like for these different audiences that aren't necessarily intending to eventually become computer scientists? And this eventually led me to doing some sort of casual, informal need finding. I didn't yet know enough HCI to do sort of full, formal, publishable need finding, but I ended up working with a lot of social scientists on their actual projects and figuring out what were they actually trying to do. In particular, the project that I was sort of collaborating with them on, I was looking at how would they be able to scrape large data sets from the web, especially in the presence of sort of modern interactive web pages that have a lot of JavaScript, have a lot of interactivity, have server backends that are pulling in a bunch of data, all this kind of stuff that makes modern web pages very messy, and they're undergoing constant sort of design changes. And all of this was really tough for these folks who had really only learned, they had maybe one semester of R or Python data analysis, and that was kind of their programming background, and they were super comfortable doing that stuff, but they weren't really comfortable doing web scraping, right? That was just something that was out of their comfort zone. They didn't have any of the tools they wanted for that. The kinds of programs they would have had to build for that were actually kind of large and complex. Even for computer science PhD students, it turns out pretty simple web scraping scripts, they mostly can't write within an hour, right? And so for these folks who had much, much less programming expertise, much less understanding of how the browser works, that was just kind of out of bounds. And so we eventually landed on a programming by demonstration tool for web scraping, where the user is basically demonstrating, here's how I would collect the first row of each table of data that I ultimately want to collect. And the tool goes back and actually synthesizes the program for collecting the next 3 million rows or whatever it is that they're looking for. So this was really helpful to me for figuring out how actually talking to the real users and observing the real users could shape a tool and shape sort of what we build into it. So sort of the next step after making this program synthesis tool was figuring out, okay, what are the lingering challenges? And this led to the creation of one of the language constructs in it called the skip block, that was basically for helping them parallelize and distribute these programs. And so basically, you just kept finding that each new challenge on the path towards giving them a usable tool was served both by HCI techniques, right? Seeing what they were struggling with, finding needs based on what was still a challenge for them, and by PL techniques, right? So, eventually you have to then design the language construct that is going to actually fix those needs and compile it down to whatever, right? So that's the kind of stuff that I just sort of kept occurring to me that we needed both throughout. And really we had to sort of co-design solutions from both the HCI side and the PL side, right? You have to figure out not just what language construct could solve this, but also what language construct will they be able to use that will solve this. It really had to be tied together. And so I mentioned earlier that my student Justin Lubin is working on studying statically typed functional programmers, right? So all of the same techniques that we saw were useful on sort of this audience of people who would consider themselves non-programmers are also useful for programmers as well. That same suite of techniques turns out to be really helpful for sort of, I think statically typed functional programmers generally have the reputation of being like the programiest of programmers. I don't know if that's legit, but. And so it's just really interesting to see the extent to which the techniques that we use in this PL plus HCI space really can translate across many different audiences.
Yeah, one thing that struck me about your story is the early point about how you didn't, the need finding you did wasn't sort of formal, and you couldn't publish it because it was informal. But I think for a lot of our audience, that may be, it may be too much to ask to actually have them do a formal need finding study that you could publish at CHI or someplace like that, and that shouldn't stop them from doing it. In
No,
fact,
absolutely.
having a few informal conversations with experts in the domain that you're interested in targeting is a really valuable thing to do, regardless of how formally you do it, right? It doesn't, even just watching people do the thing they do for their work for a few hours can be really illuminating. And it doesn't, that's, you doing that is not going to be result in a paper that on its own, but it also might result in a much more interesting contribution than on the technical side, because the need is more real. And so we shouldn't discount the sort of informal, non-rigorous ways of contributing to this intersection. I think that goes for the PL side as well, right? Like, to make a PL contribution, you're going to need to prove stuff and run some benchmarks, but that doesn't mean that doing let's call it a quick and dirty PL implementation using using one of the many facilities now, like language server protocol, other facilities for quickly implementing a domain specific language, that isn't a way of bringing programming to your audience quickly and efficiently without without having to jump through all the hoops that a PL researcher would go through to build their programming system. And the HCI community has long recognized the value of the sort of low cost approaches to collecting data from research. But I think the low cost approaches to PL can be good too.
One of the questions I often get from PL colleagues is, I think this should be more usable, or I think this should be more learnable. And I don't actually want to invest the time and energy to making an HCI publication out of it, but how do I figure out if I'm right, or if I need to sort of retarget where I'm looking in the space of possible, languages that I could build? And I always tell them, just sit down and watch a friend use it for like an hour. Maybe if you can get all the way to like 3 friends, right? Just looking over their shoulder without, intervening to tell them how to use your thing and see what comes up. Like, it's amazing the things you can find just from, spending 3 hours like that. It shouldn't be so informative, but it is.
I was just counseling a student making an interface for showing many different API examples from multiple libraries that have like the same conceptual approach. And, like we've been meeting about this for months, and, I'll give like, no, like I think this will be confusing, right? You should switch this, or like, there's so many ways in which you can make an interface more confusing than it needs to be. And I already know what this does, right? We've gotten to the limits of the value of asking me as like to give you a heuristic evaluation, right? You need to just grab your friend, grab your partner, grab someone else in the lab and ask them to try to do a thing. Feel free to like show them what each button does, like don't belabor it, but like show them what each button does, because they've never seen this interface before. But then, give them a question in their own language, not yours, and see if they can do it. And oftentimes they won't be able to, and it's not personal. It's, just like do that a couple times and you will get rid of the most important problems that would critically hamper your system. And it's even more efficient than waiting for a week to get your professor to give their expert opinion on what they think the problems are.
Well, and it finds exciting new research challenges, right? This is one of the really cool things about this space, right? People, at least I have found, many students struggle to find what is an interesting research challenge. This is just a magical way of finding interesting challenges, right? If it's something that is hard for people to do with their current tools, or with the new tool that you've been building, whatever the case may be, boy, it looks like here's a challenge that no one has solved yet, and you could try to solve it. Yeah, so let's start with PL doesn't care about people. I think a lot of programming language designers and programming language researchers actually care about this. And, even if they're not studying humans directly, they are excited about new languages in part because of how they will serve programmers, right? It's pretty rare to have folks who, don't at least think about someone using the language, whether that's them or, their friends or the people writing optimizations inside the C compiler of their choice, right? Like they have some audience in mind for the languages they built. And so, yeah, I think this one is actually pretty easy to, you can look around at the folks in PL and pretty quickly see that, okay, that doesn't seem to be true for the most part.
Just because the methods that have been used are not necessarily targeted all that well at learning lessons from users doesn't mean that programming languages researchers don't care about users. They do.
And we often make claims that, right, like even before user studies and other human factors evaluations came more into the mainstream, we were making claims about usability. It was just usually sort of, okay, we can express this program more concisely, and lines of code is sort of the best easy proxy we have for how easy it was to write it, right? Like people have been making claims about how usable our languages and our tools are for a long time. So I wouldn't love to accept that particular evidence at this point, but I think it does give an indication of the fact that folks care.
Yeah, so I think PL can't benefit from human factors research. So I think part of this is that some people think that HCI research is all about surface level concerns.
Yeah.
And
right. Font color is
large user, right? Font color and where things should appear on the screen, and all about running user studies with novices. And so what can it say about something that requires learning, requires expertise, most tasks involve days, if not years of work. I think this is just again a fundamental misunderstanding of what HCI research is and what it's worked on. People, HCI research is of course applied to font colors, but it's also most HCI research is about really complicated artifacts. Like earliest HCI research in the world was about control systems and nuclear power plants, and the interaction with programmers, in fact, and the expertise is something that's sort of really fundamental to all of that early work.
Maybe I'll use that as a jumping off point to go to HCI is all about evaluation, right? So I think I made a little bit of a mistake early on saying, oh yeah, like user studies, right? And that is exactly what, that's how I first started interacting, I think, with PL people outside of the group that I was in as a postdoc, right? Was other people funded by the same NSF grant reaching out and saying, hey, we have this new cool thing. It's computer aided programming, right? These can we show that the computer really aided them? But that is just one small part.
Right.
But in reality, it's a lot more this kind of spiral design of like, I think there's a problem. Let me see one person or two people try to do this. Okay, update my understanding of the problem. Let me play, like what kinds of solutions might address this. Let me play with that a little bit. Let me come back. Is there some low fidelity representation of the solution I'm kind of thinking about that I can put in front of another person, right? And just iteratively building up higher and higher fidelity prototypes and conceptualizations of the problem and how the approach addresses it, so that in the end, in a certain sense, like user study is not this high stakes thing. Do we find out if it's good or not? Right? It's more just confirmation.
Results probably won't be surprising, right? Like you basically know what's going to come out at that point.
That leads well into the next one, which is HCI is just implementing what users say they want. So I think this point is crystallized by the famous but apocryphal Henry Ford quote: "If I had asked people what they wanted, they would have said faster horses." So I think, one criticism we often hear about formative research or need finding is, oh, well, why are you asking people what they want? You need to, they're just gonna tell you some minor delta above what they already have, that's a lot of what we just discussed, which is that the designer, meaning you, the researcher, are fundamental to this process. It's the people you're talking to are experts in the needs they have, the challenges they face. They aren't experts in the solution space.
Like it's not just about talking to them. I have found it much more informative to watch them work rather than to interview or to ask them anything, whether that's about what solution they want or just about what they do.
There's a fancy name for that. It's contextual inquiry.
All right, so let's talk about the last misconception: doing HCI is too hard. I think this comes from again, a misconception about what people do for user studies. I think people have this idea that they have to run a 100-person user study. The IRB process is a super intensive process that takes months. In fact, most studies about programming systems are either exempt or expedited in IRB terms. So it's not that complicated to make a protocol that the IRB can approve relatively quickly. And it's not, find a friend that has some IRB experience and submit something. Don't stress about this too much. Also, IRBs themselves are very helpful. A lot of times people feel, the only interaction they have with the IRB is this sort of gatekeeping interaction where they submit something to the IRB and then the IRB says, bad on these 3 things.
Right.
If you instead have a conversation in advance, say, oh, I'm trying to do this thing. Can you help me fill out the protocol? Which category am I supposed to do? They're very happy to help. One thing we encountered while writing this paper is that there's just actually a lot of really big success stories in this space, papers that really, fundamentally combine techniques from HCI and PL to make a contribution that has a sort of enormous amount of impact. So on this slide, we're showing 2 specific examples. One, flash fill, which I'll let Sarah talk about.
Yeah, so the background with flash fill, this is sort of the most successful program synthesis tool out there in the mainstream. The idea is your inputs are a bunch of columns in a spreadsheet, and then you put in some element that you want in one of the cells of another column, an additional column that hasn't yet been populated. And so
in a specific example here, you're seeing the column that you're populating is the C column. In this case, the user wants to have the first initial of the first name space, then the whole last name. And so they demonstrate that by with the first example here, A space Kumar.
I think in this example, they've either given 1 or 2 cells, and then it has actually synthesized the program for populating the rest of the cells that you see underneath A Kumar. And basically, the idea here is that input-output example, right, where the input is Arvind Kumar and the output is A Kumar, that's actually a specification, and potentially a specification that the user will find easier to provide than the code that would actually transform those 2 first cells into the third. And so basically the goal here is the user will provide these input-output examples as their specification, and then the tool is in charge of searching through the space of programs until they find one that actually fulfills that specification. And this we don't even know how many millions of users at this point.
Yeah, I mean, it's extremely widely used. Obviously, Excel, which is built into now, it's shipped with the latest versions of Excel, is extremely widely used program. And FlashFill itself is a very widely used feature within the program. And certainly it's the most widely used program synthesis tool. So I think there's 2 things I think worth pointing out about why this is a success, both for HCI at the combination of HCI and PL. So first of all, I think they learned as part of as part of doing research for this particular synthesis tool, is that not only were input-output examples a nicer specification, but also it's best to do it with just 1 example.
Yeah.
And I think that's really fundamental. So it makes it hard, of course, because that people really want to be an effective tool in this situation. It really is beneficial if only 1 example is needed in order to synthesize the program you need. The second thing I think is really cool about this is that even if you are someone that has no trouble writing the formula to get out A Kumar, think about what this requires, right? You have to write substring, cell A1, which is where, or A2, I guess, where Arvind is, and then get me the first character, so it's going to be like something 0,1, so substring 0,1. So you have to remember whether the index is the 0th index or the 1 indexed, and then
is it substr, substring, sub?
Right. Yeah, exactly. Then you have to concatenate that with the last name and a space. And so you have to remember, is
that concat or concatenate?
Exactly. And then you have to, does it take 2 arguments, or can I do a 3? And then I have to call it twice, or can I do it with all 3 arguments with including the space? Right. So you do all that, and it's whatever. A few minutes later, I get an example, which is not too bad. Obviously, it's a fairly simple example, but it's a hell of a lot easier to just type A Kumar and say, and call FlashFill. It's done almost instantly in that case. And so, one thing that's true, I think, about a lot of research in this case is that even for people that can do the programming, a lot of these easier interfaces are easier for experts too, and they can make things that are fast and efficient for novices, or domain experts depending on the case, can help even people that are really expert programmers.
I also want to mention, so Sumit Gawani, who's the PL researcher who first invented FlashFill, he and his team have now started putting synthesis tools inside a bunch of other Microsoft products. So plausible that there's going to be more of that stuff coming into the mainstream.
Yeah. Also, the second example here is an example of a data visualization, and this particular example is something called Vega Lite, which comes out of Jeff Heer's group at the University of Washington. That group has had a series of really impactful languages, what they call a grammar of graphics. It's a grammar of visualization, a series of languages for doing data visualization. So again, this is an example where they combined PL techniques, in this case, a definition of what exactly should be visualized, what are the various variables that we want to see, how they should be encoded, in a bar graph or in different shapes, the colors, all those kind of output variables are sort of a very fundamental part of what they're doing. But we want to end now with a discussion of the key takeaways from our investigation of research in this intersection, and we've summarized it in this, two relatively pithy sentences. One aimed at ACI researchers primarily, but we're calling even more broadly than that interface designers, and the second language designers.
Right. So, like we talked about earlier, interface designers can recognize places where their understanding of what the user might be trying to do in the future is really limited. And so giving users usable programming languages in the context of those interfaces is incredibly empowering. Also, of course, with that power comes great responsibility. So we need to help provide affordances in the interface or any other types of support that help people use those programming languages responsibly. Of course, those programming languages, depending on how much they can express, people can kind of tie themselves up in knots potentially, but kind guardrails should be provided, and don't throw users into the deep end. Also, don't expect code alone. So I mentioned earlier, a lot of the exciting work on interfaces that use program synthesis do not expect code alone. They open up this multimodal space of possible ways in which humans, your users, can kind of both explicitly and implicitly, to different degrees of fidelity, express what they want, and that you can take into account all those different forms of information in interpreting their desires and trying to deliver on them as the software developer.
Yeah, I think the first 2 points are very interesting contrasts, right? What we're arguing for essentially with give users PLs is that the abstraction and composition mechanism and the programming languages are really important to a lot of real world tasks that users care about, the HCI researchers care about. Everything from design, interacting with augmented reality interfaces to smart home devices to the assistive technology. Can take advantage, the users of those systems can take advantage of these composition mechanisms. And those composition and abstraction mechanisms also support community building, because if you have these abstraction mechanisms, you can share them within the community. So for example, the users of an assistive technology, can share, if they've learned how to use their smart wheelchair in a more effective way, they've programmed it in a way that allows them to do something they couldn't do before, they can share it with another user of that smart wheelchair with a sort of the power of a programming language in a way they couldn't with a more traditional GUI interface. At the same time, if you give them this additional expressive power, give users additional expressive power, there's sort of more room for them to make mistakes in a way that harms them. And a lot of PL research is about guardrails, about building type systems that prevent programs from going wrong in very specific ways, or program analysis techniques that allow systems to avoid particular errors. In the PL HCI space, there's research specifically, for example, on preventing people from writing Excel formula that have certain categories of statistical errors in them that result in real world harms, like economic analysis that guides the Fed in the wrong direction. That's a real example. So I think that providing both a combination of this power, but also support and scaffolding for people to learn to use that power effectively and safely is a really important lesson for interface designers.
So I think we've actually touched on this issue of picking good problems quite a bit already. That really comes from recognizing that there are ways of identifying problems that are important to real users, especially that need finding approaches and things like contextual inquiry and talking to the folks who are actually doing the work you want to support. You can use those experiences of talking with them, observing them, to get a sense of what are real pressing needs in their areas. And so using those techniques to find really important research challenges is pretty exciting to us. The second one, develop theories of human capabilities and behavior in recognition of the fact that not everyone is going to want to run user studies, and that that's fine. And that in fact, we can develop behavioral theories that can guide some of our language design choices. It's really helpful if we have more of a theory built up around, okay, if we're facing a choice between A and B, well, are there any theories of how programmers behave that will help us make the choice between A and B without having to run a user study of our own? So starting to build those up in the community so that folks who don't want to be running user studies will have that to turn to and lean on. And then for cases where we don't yet have behavioral theory that can guide us, which unfortunately right now is a lot of cases, for those cases, it's really helpful if we can be getting frequent feedback, right? So putting something in front of the user that will help you answer the question, answer whether you should go down direction A or direction B, whether that's sort of a Wizard of Oz study where you are pretending to be the tool that the user will eventually interact with, or you have some kind of low fidelity, you know, here's the screenshot of the code you would be seeing, what would you do next, right? Whatever it is that you are trying to test, whatever it is that you want to explore, is there a way of exploring alternatives without having to go all the way to actually implementing it? So you can be sort of iterating on this, getting frequent feedback from the real class of users and using that to shape your design.
And then you can go into design mode and leverage any existing theories we have about what humans are and aren't good at. So we're not designing a language interface that requires humans to be good at things that we just know they're terrible at. But
my favorite, is it okay if I hop in with an example? Yeah. One of my favorite examples to give is the sort of recognition over recall thing. And just the fact that humans are much, much better at sort of looking through a list of things and saying, oh yeah, that's the one I want, than they are just remembering out of their heads, okay, I think maybe it was called X, I think, right? So sort of this recognition over recall thing is something that can often shape programming tools, programming environments, programming languages in really useful ways. But we don't always even think about the fact that that applies to sort of the design choices we're making.
So that's one of the, I think, what included in one of the Nielsen's 10 usability heuristics, which is not necessarily a theory, but it's still a good heuristic, which I think, counts here. And the other one that I found very helpful from that set of 10 is system visibility, right? So what we found was that when people were using program synthesis, by example, they would give some specification and then, magic would happen and, they out pops an answer, but without any visibility into the system, they couldn't get as far. And so suddenly problems that were unsolvable in the previous user study, once we had some visibility of the system, the right visibility, right? Exposing what was useful for them to see and obscuring or abstracting away what wasn't, suddenly they could solve the problems. They could answer the Stack Overflow questions that they couldn't answer before.
I just wanted to say about one thing about the second bullet about theories of human behavior. So I think we didn't talk as much about this in this discussion overall as we had the other bullets. So I wanted to highlight a few other things from our paper about this. So I think one reason theory is very important is that it allows you to make decisions with some evidence behind it without having to rely on getting user feedback for every single decision you make. But it does require the community overall to develop theories. So there actually are many theories. I think Elena and Sarah have highlighted some good ones already. There are many theories already out there that I think you can take advantage of in your designs. But also, when we're doing studies of humans as part of our techniques, I think it's really important to not just be thinking about, is my tool good? But also, what do we learn about programmers from this interaction with this tool that could generalize to people building other tools in the future? And that allows us to build over time a set of theories that the community respects and believes in, and then that then can save all this time in decision making when designing the next tool, the next language, the next system. And I think the second thing that's really valuable about theory, beyond just this decision making thing, is the ability to more effectively generalize from a particular study. So there's a lot of criticism, for example, of psychology research that all they do is study undergrads in Psych 101 classes. How is that generalized to the broader population? And certainly there's part of that criticism that's legitimate, and the same thing might apply to us, right? A lot of user study of programmers involve not college students programmers or master's student programmers because they're available to the researchers. But one of the arguments that psychology researchers make about this generalizability is that, in fact, no, they're testing a theory when they're doing this study with, and that theory in an instance of undergrads, and if that theory applies to undergrads, then you have evidence in support of that theory. If it doesn't apply to undergrads, then you don't have evidence. You have to say that either that theory is wrong in the context of this particular population, or the theory is wrong altogether. And so without that theory, the generalizability argument that they would make is just completely lost. So I think one value that theory provides is a way of thinking a bit carefully about through the limitations of your study design. Any study design you have is going to have some limitations of generalizability, right? It's either the tasks are too short, they're not represent the bigger task, the population isn't a relevant subsample of the broader population, et cetera, et cetera. No matter how much work you spend into it, you're not going to be running 3-year-long studies with the world's experts in an exactly representative population, with hundreds of people. It's not practical. So no matter what your study design, it's very helpful to fall back to to say you're testing a theory in the design.
Right, and just to add on to that, it's true. I mean, I think I've had increasing luck recruiting a small number of experts in the particular domain to participate within a set of, say, undergrad and master's and graduate students, right? So, but we also we don't just try to get like seats or butts in seats, so to speak, for the study that are more diverse in terms of their experience. But also we ask them now. We have a couple questionnaires that are have psychometric questionnaires, and also just basic questions about their experience with the given domain or the language, so that we can begin to look at the differences in how people respond to the interface or how well they do, given so that we can qualify our statements and say, yeah, like if people have really high need for cognition, which is this idea of like how willing you are to engage with small details, you're going to do really well in this interface. And for people who are kind of like resource constrained or have kind of low bandwidth in the moment or kind of more big picture style, they don't do as well. And I realize it sounds very hand wavy, but the idea is not that it's perfect, but that we start to kind of understand who is this interface good for, right? As opposed to like what you said, is it good or not?
Thanks everybody for listening to our casual chat. I know I had a lot of fun talking to y'all.
Yeah, thank you very much, and we're happy to take any questions you have.